This lesson is over graphing quadratic functions. Example 1. Graph the function and identify the following. G of x equals x squared minus 6x plus 8. And we're being asked to identify A, the vertex, B, axis of symmetry, C, whether it has a max or min, D, whether it's a max or min value, E, x-intercepts, F, the domain, G, the range, H, graph. For A, find the vertex. Recall to find the vertex that is of the form h, k. Looking back at the function, notice we cannot easily identify the h or k value, so we will need to go find it. To find h, it is negative b over 2a. Our b value is negative 6. Our a value is 1. To simplify, in the top, we have the opposite of negative 6, which gives us positive 6, and in the bottom, 2 times 1 is 2. And so we see 6 divided by 2. Well, that tells us h equals 3. Now that we have our h value, to find the corresponding k value, we need to plug a 3 into the function. From here, we follow GEMS, or order of operations. We have no grouping symbols, but we do have exponents. 3 squared gives us 9. Next, we have multiplication division. We see negative 6 times 3 is negative 18. Next, we do addition subtraction in order from left to right. 9 minus 18 is negative 9, and then we still have plus 8, and negative 9 plus 8 is negative 1. So we just found the vertex, which is 3, negative 1. Now let's look at the axis of symmetry. Recall, the axis of symmetry is always an equation of the form x equals h. So x equals, but what was our h value? Well, that comes from the vertex, and it would be the 3. So our axis of symmetry is x equals 3. Now to determine whether it has a max or a min, recall, you look at the a value, or the leading coefficient, specifically at the sign. Since our leading coefficient was a positive x squared, that means this is an upward facing parabola, which means it will have a low point, which simply means we have a min. Next, we need to determine what is the max or min value. Recall, this is your k value, and your k value comes from the vertex, which means our value is negative 1. For x-intercepts, recall x-intercept is where the graph crosses the x-axis, which simply means y is equal to 0. So if we look back at the original function, in place of g of x, which is the same thing as y, we plug in a value of 0. So we now have 0 equals x squared minus 6x plus 8. Since this is a quadratic, we will try factoring. Once factored, you will find this to be made up of 0 equals x minus 4 times x minus 2. Since we have two values multiplying to give you a result of 0, we set each piece individually equal to 0. So x minus 4 equals 0, and x minus 2 equals 0. And now we solve the equations individually. The first one would tell us x equals positive 4. The second one, x equals 2. So it appears we found the solutions, but remember we're looking for the x-intercept, which is a point. So since our first solution was x equals 4, as an intercept, we write that as 4, 0. Our second solution was 2, which means as an x-intercept, we write it as 2, 0. Now looking for the domain. Remember, there's only two key issues to be on the lookout for. and that's fractions and radicals. So look at our given function. Do you see any fractions? No. Do you see any radicals? No, which means there's nothing to be concerned about, so our domain is negative infinity to positive infinity. Now we're looking for the range, and remember the range corresponds to the y-axis, how far up and how far down, but this needs to be written in interval notation, so it has to be the lowest value first. Well, look back at your max or min. We said this has a minimum, meaning it has a specific low point. Well, what was our low point? Well, it was -1. And since we know exactly where it was, that is why we put a bracket. Now for the highest value, again looking at our parabola, since it goes up and it has arrows indicating upwards, then the largest value would be a positive infinity. So our range is bracket -1, comma, infinity, closed with a parenthesis. Next, we're ready to put this all together to graph. So go ahead and take a moment to draw your XY axis and prepare a T-chart. Okay, so in your T-chart, you must have a minimum of 5 values. And to make sure that we see this parabola correctly, here's the approach we're going to use. In the middle of your T-chart, your vertex will always go right there. And so for us, our vertex is 3, -1. Since we have our vertex so that we can appropriately see this parabola, we want to choose values before 3 and values after 3. So if I choose a value before 3, you'd probably think of 2. A value before 2, well, that would be 1. So we found a few values before 3. Now what about after 3? Well, that would be 4, then 5. So we have our T-chart prepped and ready to go, but let's see if we have any information from the left side that we can go ahead and use to complete part of the chart. Notice the x-intercepts. We have the x-intercept of 4, 0 and 2, 0. That means we do already have those points found. Are there any others? No, which means we need to find what happens when x equals 1. And we can do that by simply plugging a 1 into the function. And then we also need to find when x equals 5. So take a moment now to find the values. Hopefully you found 1 to equal 3 and 5 equals 3. So now that we've completed our T-chart, we're ready to plot these points and see what this graph really looks like. Once you have plotted the points, you can now draw a parabola. And now we see what this graph looks like. But we want to confirm that we've done everything right. Looking at your graph, is your vertex at 3, -1? Yes. If you were to draw a line at x equals 3, would it make the graph symmetrical? Yeah. Does this graph appear to have a minimum or a low point? Yes. Does that low point appear at -1 on the y-axis? Yes. The x-intercepts, does the graph cross the x-axis at 4, 0 and 2, 0? Yes. Does the domain go from -infinity to positive infinity? Yes. The range, does the lowest of the graph go from -1 up to infinity? Yes. So everything seems to be confirmed, which means we did this correct. Let's look at another example. Example 2, same directions. Graph the function and identify the following. This time our function is f of x equals x squared over 2 plus 4x plus 6. And we're looking for multiple parts. A, find the vertex. B, find the axis of symmetry. C, determine whether it has a max or min. D, whether the max or min value. E, the x-intercept. F, the y-intercept, G domain, H range, I graph. So in this case, the one extra piece we're looking for is we're looking for the y-intercept. So let's start with part A. As a reminder, for A, the vertex means we're looking for HK, and since we cannot easily identify it from the function, we need to go and look for it. H is found by doing negative b over 2a. Our b value is 4. Our a value is the number in front of x squared, which is going to be 1/2. So we have negative 4 over 2 times 1/2. In the top, we know the opposite of 4 is negative 4. And in the bottom, 2 times 1/2, well, that's 1. And so to simplify that fraction, we find h equals negative 4. So we have found the h value, but now we need to find the k value. To find the k value, we will plug in a negative 4 into the function, and now we follow gems. So first we'll do the exponents. Negative 4 squared is 16. Next we do multiplication and division. 16 over 2 gives us 8. And then in the middle, 4 times negative 4 will give us negative 16. From here, addition and subtraction in order from left to right. And in the end, we find when we plug in a negative 4, the result is negative 2. So our vertex is negative 4, negative 2. Now recall the axis of symmetry is of the form x equals h. So we know it's going to be x equals, but what is our h value from the vertex? Well, that's negative 4. For the max or min value, we look at the leading term, which in this case is the a value, the value in front of x squared. Specifically, look at the sign. Is it positive or negative? Since it's positive, it will be an upward facing parabola, which means it will have a min or a minimum point. Now we're being asked to find our max or min value. As a reminder, this is our k value. Your k value can be found from your vertex, and we know the k value is negative 2. Next, we're being asked to find our x-intercepts. And remember, your x-intercept is always where your y value is set equal to 0. So we take the original function, and in place of f of x, we write 0. So now we have the equation form of 0 equals x squared over 2 plus 4x plus 6. Now this problem is a bit different since we have fractions, but we do have the ability to wipe out the fractions. We can do that by multiplying the left side and the right side of the equation by the common denominator. Well, in this case, what is our only denominator? Well, it's a 2. So we will multiply the right side of the equation and the left side of the equation by 2. And so on the left side, 0 times anything will still give you 0. On the right side, we have a 2 that will need to be distributed to each of the terms inside. And so the end result would give us the equation of 0 equals x squared plus 8x plus 12. Now that we've removed the fraction, we have a nice looking quadratic, and we would need to factor. The factored form gives you 0 equals x plus 6 times x plus 2. Since we have some number times some number equals 0, we set each piece equal to 0. So x plus 6 equals 0, and x plus 2 equals 0. From here, we solve the equations individually, and we will find x equals negative 6, and x equals negative 2. Now we have found our solutions, but we need to write these as x-intercepts. So when we have x equals negative 6, that tells us the x-intercept is negative 6, 0. And our other solution of negative 2, well, that can be rewritten as negative 2, 0. Now the new part, we're looking for our y-intercept. Well, the y-intercept means where the graph crosses the y-axis. Well, anytime you're on the y-axis, your x value is 0. So, looking at the function, it means every time you see x, you will plug in a 0. And so 0 squared divided by 2 gives you 0. 4 times 0 is 0. And so we have 0 plus 0 plus 6. Well, that gives us y equals 6. Now remember, we're looking for a point. The y-intercept is a point. So to write this correctly, we write it as 0, 6, because x was equal to 0 and y was equal to 6. Now for the domain. There are two key issues to be on the lookout for: fractions and radicals. Well, did our function have a fraction? Yes, it did. Now, because it did have a fraction, we have to look a little closer. Were there any variables in the denominator or any letters in the bottom of a fraction? No. The only thing we had in the denominator was a 2, and since that was not a variable, that means we have nothing to be concerned about. So our domain will remain negative infinity to positive infinity. Now we're being asked to identify our range. Our range corresponds to the y values and the y-axis. And so again, if you look back where you determined the max or min, notice we said we found a min, which means we can easily identify the low point, which means we have a bracket. What was our min value? Well, we found that to be negative 2. If that's the lowest, what's the highest our graph ever goes? Well, that would be infinity. Now we're ready to graph and put this all together. So get your XY axis and your table all ready. Starting with the t-chart, in the middle of your t-chart, you will always put your vertex, which in this case is -4, -2. And we will choose values before -4 and values after -4. Now, here's a helpful hint. Since our function started with a fraction, we want to choose values that are divisible by the denominator. Since our denominator was a 2, that means we want to choose even numbers. So we'd probably choose -2 and 0 and -6 and -8. Those numbers will be able to be reduced easily because they are divisible by the denominator. Now that we have our t-chart prepped and ready to go, let's see if we already have any of these points from our x-intercepts or y-intercepts or anything like that. And notice we do have some information. When x is 0, y is 6. That's our y-intercept. We also know when x equals -2, y is 0. That's one of our x-intercepts. And we also know when x equals -6, y is 0, as that is our other x-intercept. Which means we only have one point left that we do not currently know. So take the time now to find the corresponding y value when x equals -8. Hopefully you found the result to be 6. Now that we've completed our t-chart, we're ready to plot these points and see the graph. We draw our parabola, and now your graph should be an upward-facing parabola. And as a way to check, take the moment now to check and see if it satisfies A through H. Let's look at another example. Example number 3, graph the function and identify the following. G of x equals -x squared minus 4x plus 5. And we're being asked to find A, the vertex, B, axis of symmetry, C, max or min, D, max or min value, E, x-intercept, F, y-intercept, G, domain, H, range, I, graph. Now looking at the function, can we easily identify the vertex? No. So we will have to do negative b over 2a. Our b value is negative 4. Our a value is negative 1. In the top, the opposite of negative 4 is a positive 4. And 2 times negative 1, well, that's negative 2. And so we can see 4 divided by negative 2 gives us negative 2. So we have the h value. Now to find the corresponding k value, we must plug in a negative 2 into the function. So every time you see x, plug in the negative 2. Now again, we must follow GEMS or order of operations. We do have exponents. We have a negative 2 squared. And so negative 2 times negative 2 creates a positive 4. But there is still a negative out in front and it must remain there. Now that we've completed exponents, now we're ready to do multiplication division. So that first leading term, that opposite of 4, now creates a negative 4. In the middle, negative 4 times negative 2 creates a positive 8. And then we still have that positive 5. Now we're ready to do addition subtraction in order from left to right. And in the end, we find g of negative 2 is equal to 9. So our vertex is negative 2, 9. Axis of symmetry is of the form x equals h, which in this case, our h value was negative 2. To determine if it has a max or min, we look at the leading term, which in this case is a negative x squared. We look specifically at the sign. Since it's a negative, this is going to be a reflection across the x-axis, which means this is a downward-facing parabola. Since it is downward-facing, it means in this case, we will have a max or a high point. Now we need to determine the max or min value. Your max or min value is always your k value, and you can find your k from your vertex. In this case, it will be 9. Next, we need to find our x-intercept, and x-intercept is where y equals 0. So for the function where you see g of x, you replace it with a 0. And now we have 0 equals negative x squared minus 4x plus 5. There are different ways to go about factoring this. I am choosing to go ahead and do the AC method and expand my middle term. When I do the AC method, I now get negative x squared plus x minus 5x plus 5. I factor the first two terms and I factor the last two terms, which overall factors into the form of 0 equals negative x minus 5 times x minus 1. I take each piece and set it individually, set equal to 0. So negative x minus 5 equals 0 and x minus 1 equals 0. Solve for x in each case. So we would have negative x equals 5, then divide both sides by a negative 1, and we find x equals negative 5. The other solution, we add 1 to both sides and we find x equals 1. Now again, this is one method to go about solving. You may have used a different method, but regardless of which method you choose, you should get the exact same answers. Since we have our solutions, we're ready to write them as x-intercepts. The first one would be negative 5, 0. And the other one would be 1, 0. Now we're looking for the y-intercept, and the y-intercept simply means where x equals 0. So we take the original function, and in place of g of x, we use the value y. And now every time you see x, you plug in a 0. And from here we follow gems. 0 squared, well, that's 0. And 4 times 0 is 0. And so we have 0 minus 0 plus 5. Well, that's y equals 5. Which means the y-intercept is written as 0, 5. Now for the domain, we only have two issues to be concerned about, and that is fractions and radicals. Notice we have no fractions, no radicals, so there's nothing to be concerned about. Our domain is negative infinity to positive infinity. Our range corresponds to the y values. And so if we look back at our max or min, notice we have an upside down parabola, and we have to list the range from smallest to largest. If we look at our graph, the lowest it would possibly go would be negative infinity. But the highest our graph would go, looking at our max value, is 9. And since we know that value specifically, we close it off with a bracket. Now we're ready to graph. So get your XY axis ready and your t-chart. All right, in our t-chart, we start in the middle with our vertex, which in this case is -2, 9. Now we can choose two values before -2 and two values after -2. They don't have to be the two closest values, they can be either values. Now looking at values that we've already found from x-intercepts and y-intercepts, I'm going to choose an array of numbers, such as -3 and -5 and 0 and 1. You may have chosen different values, and that is okay. Now when x equals -5, the y value is 0 because that is one of my x-intercepts. Now when x is 0, y is 5 because that's my y-intercept. And when x equals 1, y equals 0 because that is my other x-intercept, which means I only have to find what happens when x equals -3. To do that, I simply plug it into the function and find the corresponding y value. Hopefully you find it too, and it's going to be 8. Now that we have a completed t-chart, we plot our points. We connect them, and hopefully we have a parabola. Once you have it graphed, we check. Does it satisfy A through H on the left side? And yes, it does.